Alright, now there are two ways to classify your physical quantities, and that is into scalars and vectors. Now, quite simply put, right, a scalar quantity can be completely described purely based on its magnitude, okay? And of course, vector quantities have magnitudes as well. However, the real differentiating factor is in whether or not that quantity needs to have a direction as well to be fully understood. Scalars don't need a direction, whereas vectors have directions as well as magnitude. So very simply put, let's give some examples of scalars, right? So common examples of scalars include things like temperature, right? Temperature can be completely understood by just giving it a number. There's no such thing as temperature like 4 degrees Celsius to the left or to the right. That doesn't make sense. Right? Energy is a very common scalar as well. The energy has no direction. It's just the quantity of the energy just tells you how much energy you have. There isn't a need to describe where that energy is going. It's a little bit strange. Okay. Or even things like speed, right, can be considered scalar as well. Vectors, however, must always have a direction. So some common examples of vectors, of course, include force, right? A force definitely needs to have a direction, acceleration, velocity, all of these have directions as well. Some of the more interesting vectors that you will see will be things like area. Okay, area has a direction, which is characterized by its normal vector. Okay, and most of your field strengths, which you'll see later on, are vectors as well.